morning children. Let's continue with chapter 11, Mensuration, exercise 11.2. Before moving on to the exercise, let's discuss about the area of different quadrilaterals. Any quadrilateral can be divided into two triangles by drawing one of the diagonal. For example, if any quadrilateral ABCD is given to you, the area of this quadrilateral can be found out if the length of the diagonal as well as the corresponding altitudes to this particular diagonal are given to you. So let us call the diagonal AC as D. Let's call the perpendicular DG from the vertex D to AC as H1. Let DG represents H1 and the perpendicular BF from the vertex B to AC as H2. Area of triangle ACD, area of triangle ACD is half into the base is AC, that is diagonal, into its height is H1. Area of triangle ABC is half into diagonal into H2. Therefore, area of quadrilateral ABCD is the same as half into diagonal into H1 plus half into diagonal into H2, or as common you can take it as half diagonal into H1 plus H2. Thus, any quadrilateral, the area can be found out by dividing it into two triangles, and area of the first triangle and second triangle can be found out separately. If you are given a trapezium is a quadrilateral with one pair of opposite sides as parallel. Let's call this trapezium as ABCD. Let one of the bases AB be A and the parallel base CD, we call it as B. Let H represents the height of this trapezium, then area of trapezium can be found out using the formula half H into sum of the parallel sides A plus B. The next special type of quadrilateral is a rhombus. What is the peculiarity of a rhombus? A rhombus has all the four sides equal. It is a parallelogram with all sides as equal. There are two ways of representing a rhombus. It's a parallelogram with equal sides. Let us take the side of the rhombus as A and let the height be H. The first formula is area of rhombus as area of a parallelogram as base into corresponding altitude, that is A into H. We can also represent the rhombus in this particular shape, which shows that the diagonals of a rhombus bisect at right angles. So, let ABCD represents the rhombus. The second formula is area of a rhombus is equal to half into, let's call diagonal AC as D1 and diagonal BD as D2. It is half into product of the diagonals. The application is you are finding area of triangle ABD, you are finding area of triangle BCD and adding. Since the diagonals bisect at right angles, AO will be the altitude. Similarly, CO also will be an altitude. Thus, these are the three special formulas. Area of any quadrilateral can be found out as half into diagonal into sum of the altitudes to the diagonal from the opposite vertex. Area of trapezium, half h into sum of the parallel sides, where h denotes the altitude of the trapezium. Area of rhombus, two different formulas. First formula as area of parallelogram, base into corresponding altitude. Second formula, half into product of the diagonals, that is half into d1 into d2. Exercise 11.2, question number 1. The shape of the top surface of a table is a trapezium. Find its area if the parallel sides are 1 meter, 1.2 meter and the perpendicular distance between them is 0.8 meter. A rough figure will always help you. It's a trapezium ABCD. The shape of the tabletop is in the shape of a trapezium. Parallel sides are 1 meter and 1.2 meter. The shortest side 1 meter, longest side 1.2 meter and the perpendicular distance between them is 0.8 meter. Let's name it. Height is equal to 0.8 meter. First parallel side 1.2 meter. Second parallel side 1 meter. Area of trapezium is equal to, the general formula is half h into a plus b, which is equal to half into height is 0.8, a plus b, that is 1.2 plus 1. It is 0.4, 0.4 into 1.2 plus 1.0. 0.4 into 2.2, 22 into 4 is 88, 2 decimal place or 0.88 meter square. Area will always be represented as meter square. Second question. The area of a trapezium is 34 centimeter square and length of one of the parallel side is 10 centimeter. And its height is 4 centimeter. Find the length of the other parallel side. Area of trapezium is 34 centimeter square. Area of a trapezium is equal to 34 centimeter square. Let's recall the formula. Length of one of the parallel side is 10 centimeter. Let's take the letter A as one of the parallel side. 10 centimeter. Height is 4 centimeter. Height is given as 4 centimeter. You are asked to find out the second base. So the formula for area of a trapezium. Area of a trapezium is equal to half into h into a plus b. Area of trapezium is given as 34 centimeter square. That is 34 is equal to half into, height is given as 4 centimeter. We have taken A as 10 centimeter plus B has to be found out. You can cancel 2 and 4 or you can simplify. There. 34 is equal to, when you expand 2 into 10, 20 plus 2 into B is 2B. 34 minus 20 is equal to 2B. 14 is equal to 2b or b is equal to 14 divided by 2, which is equal to 7 meter. Therefore, length of other parallel side is equal to 7 meter. Question number 3. Length of the fence of a trapezium shaped field ABCD is 120 meter. If BC is 48 meter, CD is 17 meter and AD is 40 meter, find the area of this field. Side AB is perpendicular to the parallel sides AD and BC. Underline the words fence of a trapezium, parallel sides AD and BC. So, AB itself is an altitude or a perpendicular, and The word AD and BC are parallel sides represents that it is a trapezium. It's given in the question also. It is a trapezium. The length of the fence of the trapezium shaped field is 120 meter. BC is 48 meter. CD is 17 meter. AD is 40 meter. AB needs to be found out. So, perimeter of trapezium ABCD is given as 120 meter. Perimeter means sum of all the sides. So, AB plus BC plus CD plus DA is given as 120 meter. AB plus 48 meter plus 17 meter plus 40 meter is equal to 120 meter, or AB is equal to 120 minus 8 plus 7, 15, 4 plus 1, 5 plus 1, 6, plus 4, 10. 120 meter minus 105 meter, which is equal to 15 meter. The length of AB is 15 meter. At the same time, it is said in the question that AB is an altitude, or AB is perpendicular. We can use the height of the trapezium as the length of AB. So, area of trapezium, the formula is half into height into sum of the parallel sides, which is equal to half into height is 15 meter, parallel sides 48 plus 40. Half into 15 into 8 plus 0 is 8, 88, or can be cancelled. 15 into 44. 5 4s are 20, 26, which is equal to 660 meter square. Question number 4. The diagonal of a quadrilateral shaped field is 24 meter and the perpendiculars dropped on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area of this field. As we have discussed here, area of any quadrilateral half into diagonal into H1 plus H2. So, in this particular figure, this is a quadrilateral. We identified the figure as a quadrilateral. The diagonal length is 24 meter. H1 height, the first altitude is 13 meter to the triangle which is on the top, and the triangle which is below, the height is 8 meter. Directly you can apply the formula. Area of a quadrilateral is equal to half into diagonal into H1 plus H2, half into 24 into first diagonal is 13 plus 8. 2 and 24 can be cancelled as 12. So 12 into 13 plus 8 is 21. 21 into 12. 1 2 is 2, 4, 1, 2. Which is equal to 252 meter square. Question number 5. The diagonals of a rhombus are 7.5 centimeter and 12 centimeter. Find its area. It's a direct application of the formula. Diagonals of a rhombus. The question they said it's a rhombus. The diagonals of a rhombus, the values are 7.5 centimeter and 12 centimeter. The first diagonal D1 7.5 centimeter. Diagonal D2 12 centimeter. The second formula for area of a rhombus is half into product of the diagonals. Area of rhombus is equal to half into D1 into D2, half into 7.5 into 12, 6, 75 into 6, 6 5s are 30, 7 6 are 42 plus 3 45. 1 decimal place. So it is 45 centimeter square. It's a direct application of formulas. Question number 6. Find the area of a rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. Find the area of a rhombus whose side is 5 centimeter and the corresponding altitude is given as 4.8 centimeter. It is a rhombus. What's the first formula to find the area of a rhombus? It is like area of any parallelogram, base into corresponding altitude. Base is given as 5 and the corresponding altitude is 4.8. Immediately you can find out the area of the rhombus by the first formula, base into corresponding altitude. And now, if one of the diagonal is 8 centimeter long, find the length of the other diagonal. So the base is given as 5 centimeter, altitude is given as 4.8 centimeter. One of the diagonal length is given as 8 centimeter. You need to find out the second diagonal. So the two parts of the question, by the first formula, area of rhombus is equal to base into corresponding altitude, base into corresponding altitude, which is equal to 5 into 4.8 or 48 into 5, 8 5s are 40, 24 centimeter square. And now by the second formula, area of a rhombus is equal to half into d1 into d2, where d1 and d2 are the diagonals. Area under area you can substitute 24 is equal to half into the first diagonal is 8, second diagonal need to be found out. So 2 and 4, or d2 is equal to 24 divided by 4, which is equal to 6 centimeter. So both the formulas are applied in finding the area of the rhombus as well as the diagonal, length of the diagonal. Question number 7. The floor of a building consists of 3000 tiles which are rhombus shaped and each of its diagonals are 45 centimeter and 30 centimeter in length. Find the total cost of polishing the floor if the cost per meter square is rupees 4. So here underline the words rhombus, then underline cost per meter square is rupees 4. The diagonal lengths are given in 45 centimeter and 30 centimeter. Let's convert them into meter because based on the cost unit, we have to convert the individual dimensions. The floor of a building consists of 3000 tiles. The tiles are rhombus shaped. The first diagonal length is given as 45 centimeter, which is the same as 45 by 100 meter. And second diagonal is of length 30 centimeter, which is equal to 30 by 100 meter. The first concept is to find out what is the area of one tile. So area of one tile is equal to half into d1 into d2, which is equal to half into 45 by 100 into 30 by 100. Like that, how many tiles are there? Therefore, area of 3000 tiles is equal to half into 45 by 100 into 30 by 100 into 3000. Now, let us simplify it. What is the cost? Find the total cost of polishing the floor if the cost per meter square is rupees 4. First, let's find out the total area. Zeros cancelled and here. Now, It is equal to 45 into 3 3s are 9 by 2 meter square. Let's do the final calculation later. Cost of polishing 1 meter square is equal to rupees 4. Therefore, cost of polishing 45 by 9 by 2 meter square, 45 into 9 by 2 meter square is equal to 45 into 9 by 2 into 4. We can cancel this 2, which is equal to 45 into 2 is 90. 90 into 9 is 810. The total cost is rupees 810. So if you feel that further calculations are there, don't make it into decimals in this part. In the final answer, you can convert into decimals if needed. Revise the formulas and practice these questions thoroughly. We'll do the remaining questions in the next class.